We're going to work with denominators, unlike denominators, and we're going to do some adding and discussion about what baselines are and how baseline fractions are and how we can use, or we don't really need to use an algorithm, we can just use our brains to figure this out. So in this first sentence up here, Ada said she walked more than 2 miles to get to school. So I noticed the word more, and then I noticed the word 2 miles, and then I see that I have a little map here, and here's Ada's house, and here's the school, and then there's these fractions in between. And then here's the question. Is she correct, and how would I know? So I guess I'm going to have to add them. And then here's my hint. Think about my baseline fractions. And are the above fractions more or less than the baseline fractions? So here's a baseline. Right there, 1/2. And then I'm looking over here at 3/8 and realizing that it's just a little less than 1/2. So if I add those together, I have less than a mile. Let me do this so it doesn't get confusing. It's less . And then I have this last fraction right there. So I have 1 plus this 8/9, which is also less than 1. So we're going to have less than 2 miles. So the idea is that she had less than 2 miles, not more. And we did that without having to change the fractions at all, just by using our logic. Pretty cool, huh? So based on what we just learned, or just used, now our question is, Ada's mom says, do not go more than 2 miles. More than 2 miles from the house. And I'm assuming, and then it says down here that Ada needs to make a quick calculation to determine if she can go to the store. So here is Ada's house, and here's the store. And once again, here are our fractions, all with different denominators. Again, looks like we're going to have to add them. And I'm looking once again at my baseline. I'm going to start with my 1/2 plus 3/4 and then plus 7/8. And I'm looking for less than 2 miles. So we know when we add these two together, I actually know that 1/2 is the same as 2/4. In my head, I don't even have to do that. But when I add that together with 3/4, then I know I have 5/4. And now I have to add my 7/8. So I'm thinking, is this going to be more or less than 2 miles? Well, here's an interesting thing, because I know we have a little bit more here. We have 1 mile and a quarter, and here we have close to 1 mile. So we know we're going to have, because this is 1 1/4, and this is almost a quarter. We are going to have close to 2¼ miles, and we're not supposed to go more than 2 miles. So I'm saying the answer is no. She can't go to the store. But I'd like to know exactly. So I'm going to take this stuff away for a second. And then we're going to look at it this way. How close are we actually going to get to... we know it's going to be more than 2 miles, which means that she can't go. But how close are we? Let's do this 1¼ plus 7/8. I'm going to do it on number line because I know we love the dreaded number line. So let's try that. Let's go this way. Let's go 0. Let's go 1. Let's go 2. We know that we had force. So we know we had, because here's 1, 2, 3, 4. It's not very good. Let's make it a little better as far as being able to, a little bit better. Oh my goodness, what's wrong with this thing? Okay, so that's a fourth, and then we have fourths here. I'll try and make this a little more even. Still didn't do a very good job. All right, but we had, when we added the 1/2 and the 3/4 together, we got 5/4. So that's 1 and 1/4. That's here and here. Okay. Now we have to go 7/8. And what we have left is 3/4, because we have 1, 2, 3, and that would get us to 2, and we're not supposed to go more than 2 miles. So what's this? Is 3/4 equal to 7/8? Nope, it's not. Because if we take and we make this 8s, which means one, 2, 3, 4, 5, 6, 7, 8. 3/4 is the same as how many 8s? 1, 2, 3, 4, 5, 6. So 3/4 equals 6/8. So we know we're going to have to, we have an 1/8 left. So she's going to go 2 1/8 miles to the store, which means that our answer was correct. No, she can't go to the store, or her mom is going to get mad at her. I think that might work. Okay, so here's another completely different problem, using the dreaded number lines to add our different fractions. Here's a question. How many pounds of sandwich meat did Isaac buy? What a weird name. You could refer to him. If you didn't like that name, you could call him Fred. Just because it's easier sometimes. So this time I actually am going to use already made number lines to show you. So he bought 2/3 of a pound of turkey. And that number line, oops, darn it. Didn't want to do that. actually wanted to pull out the number line that I had, which is right here. And there's this turkey number line. Now, if you look at this number line, you'll see that it has turkey, and it's broken into thirds, and the thirds are right here. There's 1/3. There's 2/3. There's the 2/3 of a pound. So then he also had a 1/2 pound of salami. And that's this one. So see how they're marked turkey and salami, and 1/2 pound is right here. Now the cool thing about these number lines is that they're now broken up, and so what we did was we took the 1/2 or the 1/3 and we made sure there was a 1/2 in each one of them. So we divided the 1/3 in half, and then we divided the 1/2 into thirds. And what you're going to see is that the common denominator is obviously 6, because this one, when we do thirds divided, each one in half, you get 1, 2, 3, 4, 5, 6. So that's our new common denominator, that's our new denominator. And when we take the 1/2 and we divide each half into thirds, 1, 2, 3, 4, 5, 6. Okay, so we know that 1/2 is the same as 6/3. I'm sorry, 3/6. And 2/3 is the same as 1, 2, 3, 4, 4/3. 4/6. Sorry. And so then when we add those two numbers together, 4/6 plus 3/6, we're going to get 7/6. Remember, we can only add when our denominators are the same. And we have 1 whole, because that's 6/6, and 1/6 left over. And the way that looks on the number line is this. Ta-da! Because our number line now becomes 6. So here's our salami, here's our turkey, here's our bigger number line, and that is how you use the dreaded number line.